Hey guys, I'm back. This is Professor McStud, and we're going to be continuing our factoring. We're kind of wrapping all this up. We're factoring everything completely. So what does that really mean? Well, obviously, we've kind of broken it up by each little piece of our toolbox of tools to factor of polynomials. So here we're going to look at kind of sort of going through here and factoring all of these, just throwing all different examples out here to you. So let's look at this first one here. So you'll say, cube, I've never seen a cube here. Well, what we can do is actually factor out, looks like to be a 4n. So factor, greatest common factor 4n, I'm left with 2n squared minus 11n plus 7. So now I can see if I can factor, this looks a little bit more familiar. Now I can see if I can factor that. I need to see if there are factors of 14, 2 times 7, that are going to get me to 11. See, so 1 times 14 and 2 times 7, 3, 4. Okay, so that's it. So that's all that I have. None of those are going to, add to get me to 11. So therefore, I am left with just this. This is my answer. So that's kind of sort of the route that you want to take. So you're looking for greatest common factor first. Then you're going to factor out through, kind of after that, factor through a trinomial factoring or difference of two squares or anything like that. So that's it. We factored that one. Let's look at here. So don't write prime on this one. This isn't prime. This is kind of sort of something else that we kind of got into. So no prime here, just 4n times 2n squared minus 11n plus 7. On this one, I am going to, hopefully you can see that there's a greatest common factor of 4. So a greatest common factor of 4 that gets factored out. So I'm left with v squared minus 10v plus 9. Are there factors of 9 that give me to negative 10? Yep, negative 9 times negative 1. So then now I can factor that. So I have 4 times this. I have v minus 9, v minus 1. That can be factored, so that's when we come over here and we factor it this way. And then let's look at this one. You'll see you're saying, well, I want to say difference of squares because it's a minus. We have a squared term here, but this isn't a square, this isn't a square. Well, let's factor out by greatest common factor, 5, which is x. I'm left with x squared minus 25. Now that's difference of squares. So I'm left with now 5 times x plus 5 times x minus 5. Lots of 5s. So always look for greatest common factor first when you're trying to factor, then kind of move down the line. Last one, you're saying, ooh, perfect difference of squares because I have perfect square. However, one little slight detail, it's not difference because it's a plus, and then this x kind of throws it off as well because it's not x squared. If it were x squared, we could kind of go from there, but it's not. But there is a greatest common factor. Our greatest common factor here is 16x. I'm left with x plus 4. Now I've factored that. So again, looking at greatest common factor first. That's what you want to look at first. Then start trying to do your trinomials and whatnot from there. So that's what I have, wrapping up all of this factoring stuff, and now we're going to start running with this factoring in the next unit.